we just take a look at the nose here? You got an unusual little long apparatus there, and tell me what that is.
You're talking about the pitot tube. Okay, this is a designed to allow the pilot to know how fast he's going through the air. So we got air molecules coming in here at high speed, create a pressure. The pressure is measured. They compare that pressure to a static pressure of the pressure around the airplane. The difference of those two through an instrument gets them their airspeed, how fast they're going through the air.
So it's an instrumentation.
So it's basically, every aircraft that flies has something similar to this because it's so important for the pilot to know what the airspeed is that he's traveling. This one has another little dog legs. One of the younger kids walked up and said, "That looks like a microphone." Well, yeah, it does, but it isn't. This is actually designed to measure the angle of attack of the airplane. So when it's slow and close to the ground, it flies at a critical angle of attack, which is defined as the relative wind and the angle of the wing. So we have to know what that is in order to fly the airplane, and that's what this piece of instrumentation does.
Well, it seems like this would be very vulnerable, being at the very forefront and traveling at that speed with all that friction that it would just glow white hot.
It gets hot. It gets hot. You know, the leading edges of these things, you know, several thousand degrees of temperature at speed. And yeah, they just make it out of some pretty strong stuff.
Is there any type of cooling system?
I don't know if there's a coolant system for this particular boom. But there are several ways that they cool things. They use the fuel as a coolant, basically. It carries the heat, absorbs the heat from the skin, and actually keeps the inside cool.
So this thing's one huge flying fuel tank, then?
Well, it is. Pretty much everything behind, where the nose gear is, all the way back to the back end, including the wings, is all fuel tank.
Could you just describe the reason for the shape? For this unusual shape configuration?
Well, the shape is mostly driven by the performance requirements. In order to go fast, you have to have minimal frontal area. You have to be able to have a place for large engines, and it just kind of falls out. The design, you know, in the designer's mind, he has an idea what it is, and then when he gets done with it either works or it doesn't, and they make small changes to make it work better. And so this one never changed much after the initial design because the designer, Kelly Johnson, was brilliant. I mean, when he built it, he pretty much built it to do the job it was supposed to do, and it did it very well.
In addition to the design, the shape for streamlining performance, is there some type of a stealth capability with cross-sectional considerations?
Certainly, there are stealth features of the airplane. The fact that it's very thin from the side,
the profile.
You know, so when you're looking, a radar shooting it from a distance, it's a very small cross section. You notice that the vertical tails are canted inboard, and that will reflect radar energy off in a strange direction versus back to the radar receiver, and so therefore it's more of a stealth feature as well.